right. One more quick representation of a vector via a basis. I'll try to make this one quicker than the last one and just go ahead and do it. So let's say here's the basis. And suppose the basis is the following. 1x. I don't want to do that because I almost gave the standard basis. Nothing wrong with that, but I don't want to give the standard basis actually. So how about 1 x minus 1 and x squared plus 1? And we'd have to check to see that that's a basis. A basis for what? Well, that's a basis for P2, the second order polynomials. And you can check it out. You'd have to set up a system of equations and unknowns to make sure that you could actually write any second order polynomial as a linear combination of these three. But you'll see that you can. So more importantly, though, let's take a particular vector. Let's say that V is the vector 3 minus x plus 2x squared. And we want to find the representation of this vector with respect to this basis. So in the jargon of the book, or the symbology of the book, we'll say the representation of V with this particular basis. And that's what we're looking for. That's what we're trying to find. So how do we do that? Well, we need to find an A such that A times 1 plus some B times the next vector, x minus 1, plus C times this vector, x squared plus 1, is equal to V. Now, I could have just written it down, but I ran out of room there. Okay, so let me write this. Let's simplify this a little bit. So we have A plus bx minus 1, or I'll just write it a little more neatly, x squared plus 1 is equal to 3 minus x plus 2x squared. Remember, if that is a basis, then we're guaranteed that we can do this, or it's guaranteed that it exists. It doesn't mean we can find it. Maybe we don't have the skills, or we're not clever enough. I don't know. Let's just go ahead and multiply this out. You can see certain things by looking at it. Like let's just go ahead and do that. Here's the only x squared term. So I do notice right away that C's got to be 2. Forget it. I won't try to be clever. I'll multiply this out. Let me just multiply this out. So we have A plus bx minus b plus cx squared plus c equals same thing. Let's group like terms together. So A plus c, that takes care of the coefficients of x to the power 0. Oh, well, yikes, I almost forgot one right there. Sorry, minus b, what's that? And then that's the only x term. So plus bx, let's see, and that's the only, there's the x squared term. So plus cx squared, and that's supposed to equal 3 minus x plus 2x squared. So right away we see that c has got to equal 2, because those two have to match up. And while we're at it, we see that b has to equal -1. There's no other alternative. Now, what does that mean? We know that this right here has to equal 3. So a plus c, which is 2, minus b, so plus 1, that has to equal whatever this is right here. So 3. Now that's just, look, this is just, it didn't have to come out this way. It's kind of cool. A equals 0. That's, it's not always going to equal 0. It just happened to come out this way. As a matter of fact, look, if I had chosen any other number here, it wouldn't have come out that way. But, maybe it's a gift and I'll take it. So we found the representation. The representation is A is 0, B is -1, C is 2. And we can write it as follows. A was 0, B was -1, and C is 2. And I can actually write it like a vector. As a matter of fact, it is a vector. If I think about these representations as n tall vectors in n space, so the representation I can think of this way. The other way to think about it is, honestly, you could think about it like this if you want. This may look a little weird, but watch. Hey, sometimes people will write it like this. I'll put a little b down there because it's with respect to this basis. Now, I could write it like this. I could say 0, -1, 2, which is in the style of, ordered pairs or ordered triples. But I got to make sure that I put this. I got to really make sure I put that down there. And I probably might want to put it down here. Now it's clear because I have this equals this equals this. These are the coordinates. So we refer to these as coordinates. But it's the coordinates of the vector v with respect to this basis. And so there's my solution. 2 ways to write it. And 5 minutes, not too bad.